Good day guys, welcome to another tutorial on FIS 309. My name is Olasende Faith, and in this tutorial I'm going to be treating concrete tank. So let's get started. Now, construction of a concrete tank, or some people call it a block tank, some people call it concrete pond, whatever you call it. It's just simply all those kind of ponds that are constructed from blocks, concrete. Yeah, usually concrete. Usually it is rectangular in this form. It is usually sometimes rectangular and sometimes it is circular, or some people call it cylindrical. So this is more like a rectangular pond where you have blocks, blocks here and there, blocks here and there. Then it goes like that. So I believe we get the idea. We generally get the idea. Don't mind my illustration, it might be bad. Generally get the idea of block tank. So this block tank might be rectangular and some might be cylindrical, where it looks like a cylinder. Some people might not use block itself. Some people might use plastic sometimes to form this cylindrical, and those that have the money might use block. So we generally get the idea. Now, how do calculation based on all these concrete tanks, block and then cylindrical? So let's start with block. Now, rectangular block tanks. From the name rectangular block tanks, it has a base that is a rectangle. And firstly, let's know how to calculate the surface area. So the surface area of this rectangular block tank is actually easy. It's actually the area of a rectangle, which is length times breadth. So let's take this place is 60 meters and let's take this place is 20 meters. So the area of this will be 60 times 20, which is this meter square. So it's as simple as that. That was the surface area of a rectangular block tank. Now let's get the volume. If you are getting the volume of a rectangular block tank, then the volume is length times breadth times its height. So now it's not left to you to calculate the height. This will be the height. Then all you just need to do is multiply the height with it and you get your answer. So let's take that it is 1 meter high, or let's say it is 2 meters high. So the height will be now, then the volume will be this meter cube. So if this is the volume, then we know the volume of water that can fill it, then, and it goes on like that. So that's the volume of a block tank, rectangular block tank. Now how do we now get, because rectangular block tank is made up of blocks, all these blocks, Agbajelola block industry, all those blocks that they do, it's actually made up of, it's what makes up this block. So we also need to have the idea of what a block is. So this is the illustration of a block. The length of a block, we need to know the standard length of a block. The standard length of a block, I think it's two kinds of block, but the one they use mostly in FIS is this 18 inch block, and the height should be 6 inch. I can't remember clearly, and this should be 4 inch. But what we are really concerned about is this length, 18 inch block. I think, yeah, 18 inch block. I think there are also there are some blocks that are 9 inch long, half of this. But what we are concerned about is this 18 inch block. Okay, good. If they are using an 18 inch block, question might come like, how many blocks would make up a block tank? So before we get there, let's assume this is a rectangular. Let me draw a rectangular tank. This is a rectangular block tank, and sometimes you use, I don't know if you have heard of something coarse. They call it coarse, a 4-course block tank. What this coarse means is, if you are counting the number of layers, block layers you have on the block tank, it is 4 block layers. So that means you have one, if you are looking at it straight, this is one block layer, this is one another block layer like this is another block layer like this. So this is one course, this is 2 course, this is 4 course, 3 course, and it goes on like that. There's 4 course. So that means these layers like this, they are called course. I believe that is cleared. So now, okay, now you might not be asked, okay, if this block tank is a 4 course, it is a 4 course block tank, then how many blocks would you require to construct this kind of block tank? I remember when we were doing it, somebody just shouted, say they've turned us to bricklayers, you know. Well, anyways, so we already know what the idea of we already know the dimension of a block, so it will be easy for us to know the number of blocks that can fit, that can help us construct a 4 course block tank having this dimension. So now the first is, let's know how to even calculate the perimeter, because it's the perimeter that would make us know the number of blocks that can be used to construct this rectangular block tank. So the perimeter of a of a rectangle, I hope you still remember, is 2 length plus breadth. So 2 length is 60, breadth is 20, 280, then 160 meters. That's the perimeter of this block tank. So if this is the perimeter of the block tank, now we need to convert, this is the length, it is the length that forms the block tank, is the length of the block that forms the length of the perimeter. I hope you remember. So it's the length that we are actually dealing with. It is the length like this that we're actually dealing with. So we need to convert this one from inches into meters. So the conversion is you multiply it by 0.0254. That will give us the idea in meters. And checking calculator, so checking calculator equals to 0.4572. So this is it in meters. So having known this, we can then say, and to know the number of blocks that will form that course that we have done here, it is 160 divided by 0.4572. You are dividing 160 by the number of the that of the block. So calculator, which is 349. So let's just as approximately 350. If we're approximating it, 350. So 350. The number of blocks is 350 blocks. Now remember that this perimeter is what we have just done for one course. And remember that this is a 4 course block tank. So that means if you are putting another course on it, that's the same number of blocks it will use. If you are putting another course on it, that's the same number of blocks it will use. Now, and we said it is a 4 course block, so you have to multiply this by 4. So that should be, if I'm right in my calculation, it should be 1620 blocks. So I hope we understand that, and that's just the idea of rectangular block tank. And let me just quickly go over it again. To get the area of the surface area, you use length times breadth. To get the volume, length times breadth times height. And to get, in case they give you, sometimes you might not be given the height, you might be given in course, 4 course wall and so something like that. I had to calculate the number of block tank, the number of blocks that you can use to form that kind of block tank that has a 4 course wall with a dimension of 60 by 20. So this is how you calculate it. First, you know the perimeter. You first know the perimeter of the block tank. Once you know the perimeter of the block tank, now divide it by this value. You get the blocks, number of blocks, and that one is just for one course. So in order to get the remaining course, just multiply it by the number of courses you have. Then you get the number of blocks that will be able to form rectangular block tank. So that's that about a rectangular block tank. And if it were a circular block tank or cylindrical block tank, it's actually simple. Just to know the formulas. The surface area will be pi r squared, area of a circle. And then if you are now talking of the volume, that will be pi r squared h times height. And if you are talking of the perimeter, the perimeter will be the circumference of a circle, which is 2 pi r. And that's basically it. You can then follow with the same idea with the rectangular block tank. I hope you understand what I have said so far. In case you don't understand, please drop a comment. This is just a bonus video. I got some questions for some people to help solve, and I felt that it would be nice to solve it generally for everybody. Now, following a feeding table, though I don't really get this question well, but then I think I understand the idea. Following the feeding table, feeding for fish 12,000 grams. Sorry, 1,200 grams is 2.5%. This percent, I don't understand, maybe percent of their body weight or maybe kg, well, whatever it is. And you have a pond of 1,500 fish and an average weight of 200 grams. What is the daily feeding level? So I think this one is just still basically relation. You just have to, all you just have to do is relate. So if the table says that fish at this weight should consume this percentage, maybe of his body weight or so, I don't know. Now you have a pond that has this number of fish and their average weight is 200 grams. What will be the feeding level? Basically, all you just have to do is know the total weight of your fish, of the fish. That will be 1,500 times 200, and that should be 30,000 grams. So all you just need to do is do the relation, just like I said. The remaining is basically relating based on mathematics. So cross multiply, x will then be 2.5 times 30,000, abi. I think I've added more zeros. 1,200 yeah. Then the rest is just mathematics. You cancel and get the answer. So that's just basically it. It's about understanding relations. And the next question here is, if the initial weight at stocking is of some fish at stocking is 5, 10 and 250 grams, and at harvest their final weight was found to be 600 grams, 800 grams, 1.5 kg, what is the total weight at harvest? This one is just to confuse. The initial was just to confuse or just to give extra details. The total weight at harvest is actually this weight all summed up: 1.5 kg, that's 1,500 grams, plus 800 plus 600. Just sum everything up, and you get the answer. This should be 4, 9. I think this should be it. So it's just basically that. Since the question is at harvest, the final weight. So now what is the total weight at harvest? Is actually this final weight. This initial was telling that before they stock them, this was their weight. Now after they harvested them, this is their weight. Now is the total weight. Is also sum everything. The total final weight is also sum all their final weights up, and that's just it. I hope you enjoyed this. Please like, share, subscribe, tell your friends, and thank you guys for the subscription so far. I'm really grateful. I'm very grateful, and I wish you all success in your exam. Peace.